So, well, first of all, thanks for having me today. It's my first presentation at PyData. And thanks to Adam, who invited me. And today I would like to present to you some project that I did as part of my work, but it's not my usual daily task. Just some background, because we basically had like opportunity to do some innovation in our company. We normally take care of you finding a new job and stuff like that. And this was meant as a prototype. So it just had to have some connection to what our company, LMC, does. And well, probably when you are thinking about searching for a new job and what you see on the screen, it might not be obvious, but we will get there during the presentation, I hope. So I will tell you about my sign language recognition prototype, I would add, and because it's like work not finished. And okay, let's just get to it. So I always included some handy title on top of the screen. And this one is, why would I do such thing as a sign language recognition? So I thought like, what are we not doing at LMC? How can we help more people? And I thought of people who are hearing impaired and that they might have some troubles during normal interviews. If you imagine that you have some hearing issues, or you just are plain deaf, then how are you going to have call with someone from HR, from your future manager? What are you going to do? It must be difficult because you are basically limited to jobs that are supporting hearing impaired employees, or communication via emails, messages, etc. So I imagined that my prototype could help people doing natural communication both ways. And you don't need a translator, which is currently how it's done. When there is a person with this disability and they are looking for a job, there are certain companies, non-profit companies, that provide a translator free of charge, and he's present. But of course, it requires some funds, etc. So it's just a complicated mess. So if you imagine that someone would just be able to speak the sign language to their computer, and the person on the other side who has no idea what sign language is and how it works, like me, by the way, I don't use sign language. I went to this prototyping phase and I have no idea how to use sign language. So how can they do that? And this was one of the things how it could be solved. Now I'm going to tell you what was like the dream way, okay? Like I wanted to make the path clear from the start to the end, but I knew that I'm not going to. I had like 1/4 of the year to work on this, and it was just part of my time, so I could not take care of everything. But like, if anyone wants to do this from start to finish, you should start with real-time transcription of sign language, of course. So someone will be signing in front of a webcam, and the live video will be converted in some way to text or subtitles in that video. Then there is an issue, as I found out later. That's how little I knew about sign language and the whole community and how it works. Is that actually what the people are signing is not like in our case Czech language. It's like a different version of a language altogether. So I have here some, because the whole thing was about planned for Czech sign language. So you have here both Czech versions and my poor translation to English. So like, if you are asking, would you like water, tea, or coffee? What you actually say in sign language is like, want, water, tea, coffee, want, which states that it's a question. But you are like missing some part of that sentence, you know, like whole grammar is just gone, but the hearing impaired people, they are used to it, it's their language. This issue, or this I don't know what to call it issue, but now I have a lack of word. But imagine that you are communicating with someone who is only used to speak with sign language, and they send you an email. It might not be perfect Czech if they speak Czech, or I imagine in other languages it will be very similar. So it will not be the perfect language that you know, that you are used to write and speak. So there are ways how it can be expanded, the what I would call written sign language, into full sentences. Of course, these days you all of you know the fancy ChatGPT and other transformers probably. So you know that we can basically these days just write few words and generate an image. So something like expanding the sentence structure should not be an issue. And then, of course, you can convert back the text from the subtitles to speech. So the person, the interviewer on the other side, for example, might hear some voice, even though it will be like a, I don't know, Siri or someone, you know, talking that way. And of course, the other way, speech to text, that's like a common application of AI and machine learning these days. You have Whisper and other transformers that converts speech to text. I would mention Siri again, but if you are using Siri, it's not really converting well. So. In my prototype, I focused, due to time restrictions, mostly to the first part. And that's the transcription of sign language to text or subtitles. How to do that? How to get from the signs to text? So first of all, you need to do some recognition of the hand and body. The camera, the computer need to know what it sees, that it's a person and they're showing their hands, or it's their body, their face, and all of that. It needs to do it from live video in real time. That's like, it looks like a minor thing that it should be in the live video, but we will get to that. And then when you have that, you just need a lot of data. You need basically images with all signs that you want that your model can recognize. You can, for example, convert them into some coordinates and stuff. That's what I did. That's why I'm mentioning the point 3, converting the images into some coordinates, just like X and Y, where all different parts of hand and body are. Save it as a data set, and then hurrah, you can do your machine learning model training, and then, well, I'm not sure about that profits. That probably shouldn't be there, right? But surely someone will think that they can profit from that, but it was just as a joke for you guys. Okay. Now again, we are getting deeper. So the hand detection in the webcam video. After some tries, some testing with how I can detect hand from webcam, I found some difficulties. That's basically, it should be, the solution that you are looking for should be independent of the camera that you are using, of the light conditions and everything. I didn't have time to find my own solution, especially once I found that there is existing open source solution, so I did not have to, and I could move on. That solution is called Mediapipe. It's an open source framework. I think it now belongs to Google for some reason, but they kept it open source. And it can do many more things than just what I was focusing on, which is hand detection, face detection, and to some extent pose or like body detection. There is like, you can have a whole face detection and tracking eyes and everything, and you can use it for detecting when you play basketball or something, and how your shooting technique is going, and all of that. It has many libraries, but let's focus on hands for now. Even a simple hand, like mine, I would say, I have a pretty regular hand, has 21 points. We will call them at some point degrees of freedom, because all of them can move independently. All of them are shown there, because we are at PyData. We start from 0, of course, as the first index, so that's why it only goes up to 20, but there is 21 of them. So the first step, what I did with Mediapipe, was to make sure that I can detect all parts of my hand, and it basically just works out of the box. You can get this in few minutes, hours, depending on your skill. So this is just like testing. You can see here in my poorly made looping video that it tracks my hand nicely. And that's the first step that we need. As I told you, we will be converting images of the signs to coordinates. So each of those points has 2 coordinates, x and y, like vertical and horizontal. Those will be values that we will be saving, and we will work with them. You can do more things, as I said, with Mediapipe. There is a library called Mediapipe Holistic, which allows tracking the whole body, which at some point you will need for the sign language recognition, because it's not just the hands. If you are not familiar with sign language, like I wasn't, and you pretty quickly find out that it depends how high your hands are with respect to your body sometimes, and it's like a whole body language. So of course you need to track the whole body, but and it is possible. But still, to keep things simple, I focused mostly on hands. It was pretty much to do with the 2 hands. So what you can do is that you have a tracking of the hands independently. You can even set in the library how many hands do you expect in the picture, in the frame of your camera. And with a little bit of tweaking, you find out that there is even pretty reliable way how to tell which hand is left and right. You might think that it's showing right because it's my left hand, but it's actually like I don't have it mirrored. It was more convenient for me to look at it like it's a mirrored webcam. Of course, at the end I would just flip the whole image and it would work right away. So don't be confused. Imagine that I recorded this through a mirror, and as you can see, it records my left hand, right hand. It really does not do that because of how I'm showing the hands. I'm just doing it to make it clear. You can see that at some point there are 2 right hands, like now, and it doesn't have any issue with that. It just works, and the deep neural network that is behind it, or the model that is from the neural network provided by the Mediapipe framework, is not just tracking the hand, it tracks the orientation. So it like knows that it's looking into the palm of your hand or the back of your hand. Of course, what we need is that for some signs, we need 1 hand. For some, we will need 2. And it should know when they are both there. So another step was to make sure that it knows what frame it's looking at and where to expect the signs to be, which is what this part is doing. You can see that when my other hand appears there, it makes the whole frame larger, and that's what it will expect. When just 1 hand is there, it will try to detect the sign from that. When 2 of them are there, it just expands, and there we go. So, as a person who does not use sign language, what do you do when you want to make the data set and you don't want to just download something off the internet and you want to make it yourself? So my basic data set was just, as a proof of concept to do something with some small basic data set, which in my case was, I call them testing signs. So like something that you would probably expect, like hello, stop, thumbs up, thumbs down, call me, okay, stuff like that. I made up 17 of them, trained first models, and tested it. Then I decided to use something real, which is Czech sign language. Thanks to many YouTube videos and other sources that taught me what Czech sign language is. I was pretty sure that I know that, well, like from all the camps that I went to when I was a kid, but it's not it. Some signs were pretty different to what I knew. But I made it to 26 letters. I could merge the data sets with my testing signs, of course. And the issue was that I had to make like 200 images for each sign. It took most of my time. But that was not the biggest obstacle. We will get to that as well. But for each sign, as I said, we will be saving 84 values in an array. Why 84? Because as I told you, we have 21 degrees of freedom for each hand. There are two hands, and you have horizontal and vertical, so you need all these values. Then we get to the model. When I had the data set, I could see what I can do with some simple machine learning models. So I tested classifiers. And surprisingly, all of them had like no big issues to having some good results or providing good results. So from those 4 that you see here, I decided at the end to go with decision tree classifier, and it's for one simple reason that I could easily tweak it because it's very straightforward what the decision tree is doing. And there is really no other reason than that, because the results were similar. Decision tree classifier was the one with the top accuracy and other metrics that I measured, but it was pretty clear for explanation to others and easy to do some tweaking where needed. So I took the dataset, as I told you, 200 images each, and did some clearing of that, cross-validation, and the final model had decision tree depth 15, which means that there were like splits, and the last level of the decision tree, for those of you who don't know how the decision tree classifiers work, is just basically like trying to split, in this case, your coordinates into 2 groups mostly, and then like it can cascade, so like every point will drop somewhere. We have 15 levels, nothing difficult. In this confusion matrix, of course, we want, that's like what we predicted, what was the truth. We want everything to be on the diagonal. Sometimes it doesn't work that way. That's why our accuracy and other metrics are not 100%. But that's not the end of story, of course. I mentioned many steps, but even the first one could not be done properly. And the main reason is that in Czech sign language, most of the signs are what I call dynamic. They include some movement. It's not like I show you letter I, and I stand there and I give time to my recognition to know that it's the sign, but there is some movement, here and there. If you've seen the hearing impaired people talk, you see that they are just moving constantly. It's a dynamic process. And there is not an easy way how to say where one sign ends and the other one begins, because sometimes it's just like the motion continues and the meaning is different. But of course there would be a way, but like now I'm telling you, if you do this later, if you will work on this, then this is what you should take care of. And I mentioned it through my presentation. It's more than hand detection. You need to do whole body detection. There are some signs that differ, like how it's the same sign, but it depends how far your hands are. So you need to have some you need to take it with respect to something, and of course it's the best to know where the rest of the body is. From top of my head, I remember that there is a word for spinac, and if you confuse it and the length, like the distance between your hands is wrong, then you get a bad word. So you don't want to mess things up. And you use your not just hands. It's combination of where your hands are. You show something around your head and stuff like that. So that's why eventually that's, for example, as I showed, that Mediapipe holistic would need to be used. And then eventually you get to other issues, how to keep adding some processing of each frame, but keep it without stuttering and have everything done in each frame of the live streamed video. I believe it can be done. Just, it requires a lot of time and effort, and I would say more manpower, because it's not a task for one person. There were actually programs from Charles University here in Prague a few years ago. I found out their grants. They received like a grant for a few millions, and they were working on this. It was around the year 2010, and there are apparently no results from that. There is no app that was as a result of this. And well, I conveniently wrote here, thank you, but there is a different slide behind this, and that says showtime, but there is one condition, that this showtime will be actually done, and that I don't know what the light conditions here are. I said that I try to do my program as light condition independent as possible. That does not mean that if it's too dark here and my webcam will not see me, then I of course can't do anything about it. You've seen here some of my code. I decided to, for my convenience, I had everything in Jupyter notebooks, but this one was already converted.
Perfect condition, so you don't have any excuse.
I think I will do it. My wife always tells me that I'm a pretty loud person, so I believe if I a little bit raise my voice, then you will have no troubles hearing me.
Even it's recorded if he speaks and it's not on.
Yeah. I think it should be taken care of. And now, of course, it will start misbehaving for me, because every time someone tries to do anything like, hey, guys, I'm going to show you my code, then, all hell breaks loose. So, and of course, when 50 people or so is looking at you, then you don't even remember where the letters on the keyboard are. Let's try. It just takes some time to boot up, because in the beginning I'm just stupidly importing whole TensorFlow and stuff, which takes a lot of time. And we will see how it's with light.
As I said, it's a prototype, so it's kind of moody, I would say. But when we tested that at our work, then we should be like, I still kept there the detection of which hand it is, so I can just wave around, you know, and show that what I was showing you in the presentation, that it still detects where my hands are, and I can just, you know, try to confuse it, like it's on the right side, but it still knows it's left, you know. And you know, the letters, some of them are pretty easy. It knows that now. And at some point you get to some variations, you know, like you have D, and you see that there is just a minor nuance between D and P, but of course, even in real life it is, right? If I show you like this, at some point you will start considering, is he still showing D or is it P? You can see that sometimes, you know, when I'm doing like this, it gets pretty confused because it always wants to show some result. I intentionally kept there that when it's like, I think now I have like 60%, when it's sure, then it shows at least something. So you can be more strict, you can set like 90% and make a condition that it will not show anything if it's not at least 90% sure. But you know, it's still from my testing phase. For that reason, I had this, and you can see that sometimes I can confuse it. It's not perfect. It was like the time remaining for doing some final tweaks was just few hours. So that's the state that I left it at. And sometimes it, you know, required really that you have like, for this is really Z in Czech sign language. You know, I always thought, as I said, from camp that Z will be something like this, you know, but it's not. So, but you know, for something that was just tested, basically it was trained on few images of me, but later, maybe after all the presentations, I can keep this running. You can come and see how it works with your hands, which are different. They will have different distances of all those points. It might work for you, it might not. It was just straight rude with one of my colleagues when he was showing some signs, and it told him that everything is just thumbs down, you know. But it really depends, and this can be easily solved with including more people with more images into the data set, and then this issue basically disappears. And I told you that the idea is that someone would be signing during a call and it would show subtitles or convert in some way in the signs into text for the person who is on the other side. So the other version where it's not real sign language, it's just maybe some of the signs really exist, but that's just my stupid data set of 17 signs that I made up. So you have like, and thanks Heureka for a nice background, because sometimes I was lucky enough to, okay, it tells me to stop because there's stuff also. But sometimes I was presenting this with yellow t-shirt like I have today, and then you don't see a thing. So there's like peace, and you know, just like that. This is how it could work. It's just simple condition, you know. It's writing everything in a stream. If I made so many signs, which I don't think that I can do now very quickly, and it would actually fill the whole line, then it will make the old ones disappear, you know, like what you would expect. Yeah, it's working. And after some time, they just disappear, you know, like you would expect from normal conversation. And this is how it should work. That was the idea how it would work. But there is still many obstacles on the way how to do this. I can tell you that like 1 week after I did this, Snapchat included in their app American Sign Language alphabet. So I felt pretty proud because, you know, I could say that they basically got the idea from me. Thank you very much. That's all from me.